Welcome back, dear students. Today we are going to start coordinate geometry for A levels. This is an integral part of Pure 1. I have already delivered the lessons for coordinate geometry for O levels, and you can find the link of the videos there to recall what you studied regarding coordinate geometry in your O level exam. Let us start today's topic. Today we are going to learn about gradient of a straight line. What do we mean by gradient? How do we calculate it? What is the formula for calculating the gradient of a line? And what is the relation between gradient of parallel and perpendicular lines and the collinearity of 3 points? So let us start. Dear student, gradient is very important concept in coordinate geometry. Gradient basically is the tangent of the angle formed by any line with the x-axis. You see this line? This is the line over here and it is forming angle theta with the x-axis. Gradient written as m. This is basically equal to tangent theta, where theta is angle formed by the line with x-axis. You can see over here as well. M is equal to tangent theta. Now you see this line. I have spotted its 2 points. This point is x1, y1 and this point is x2, y2. x2, y2. So you see, if I draw a line parallel to x-axis over here, this angle will be same as this line forms with x-axis. So I am taking tangent theta from this graph. What are the coordinate of this point? x1, y1. So what will be this? What will be this distance? This is x1. What will be this distance? This is y1. And similarly, what will be this distance? This is x2. And what is this distance? This is y2. This is what? y2. This is what? y1. So what is this distance? This is y2 minus y1. So length of this adjacent opposite side is y2 minus y1, and then this adjacent side is x2 minus x1. So from there you can write tangent theta is equal to y2 minus y1 over x2 minus x1, which is the gradient. So what we have learned through this brief discussion, that if we are given any 2 points of a straight line, x1, y1 and x2, y2, we can find its gradient with the help of this formula. What gradient is basically it is the tangent of the angle formed by any line with the x-axis. This is denoted by m. It is calculated by y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are any 2 points of a straight line. Let us solve some questions. There are 4 parts. In each part we are given 2 points, x1, y1 and x2, y2, and we have to work out the gradient of the line joining these 2 points. Solution to part 1. What will be the gradient? Gradient is y2 minus y1 over x2 minus x1. What is y2 over here? 17 minus what is y1? 5 over what is x2? 10 and what is y2 x1? 4. Upon simplification we get 12 over 6, which is equal to 2. For the second part, x1 y1 is equal to 0, 6 and x2 y2 is equal to minus 4, 8. So what will be the gradient? Put the values. y2 minus y1 over x2 minus x1. This will be 2 over minus 4, which will be negative 1 over 2. I hope you can solve the third and fourth part by yourself. We have so far learned about the gradient. We have learned that the gradient of any line is the tangent of the angle formed by the line with x-axis. And secondly, we have learned to calculate the gradient of any line if its 2 points are given. Dear student, now we need to understand the gradients concept in detail. There are two lines. If I extend these two lines and intersect these lines with x-axis, you can observe this angle formed by the line theta is acute angle. And if I perform the same operation for this line, you can see that this angle formed by the line with the x-axis theta is obtuse, greater than 90. I hope it is clear. Now, what we have to learn is, we know from the trigonometry that any angle which is between 0 and 90, its tangent is positive. And any angle which is greater than 90 and less than 180, it lies in its terminal arm lies in the second quadrant. So tangent theta is negative. That is, gradient will be negative. As we move from left to right, if the line is rising, like in the first case, if the line is rising, its gradient will be positive. And if as we move from left to right, if any line is falling, its gradient will be negative. Gradient of the line will be increased if angle with the x-axis is increased. Look over here. What is tangent 0? Tangent 0 is 0. If a line forms the angle 0 with the x-axis, its gradient will be 0. If this angle is increased a bit, gradient will become positive and will increase. Further, by increasing this angle, gradient will be increased again. As soon as the angle is less than 90 and it is increasing, gradient of the line goes on increasing. But if angle is greater than 90, its gradient is negative. We will learn in trigonometry as well, tangent is strictly increasing function. It always increases. It means the gradient also always increases. But the gradient of the line which is parallel to x-axis is 0 and which is perpendicular to y-axis, if this angle is 90 and tangent 90 is not defined, so its gradient will be not defined. Some people say that gradient will be infinity, which is basically mathematically wrong. The gradient will be not defined. I am drawing this line L1, then L2, then L3. Which one is the steepest line? L3. So it has the greatest slope. And this line is parallel to y-axis, upward, vertical. Its slope is undefined. This is the steepest line, but its slope is undefined because tangent 90 is not defined, does not exist. Similarly, if we see this line L5, gradient of all these three lines is positive. Suppose this grade, its gradient is 1 by 4, its gradient is 1 by 3, its gradient is 2. Positive, and the greatest value of the gradient is for L3. Then L4 has undefined gradient and L5 have a negative gradient. So which of the following line has the least gradient? It is L5. So from here you need to learn that if a line is rising, its gradient is positive. If a line is falling, its gradient is negative. If a line is horizontal, its gradient is 0. And if a line is vertical, its gradient is undefined. Some people say infinity, but I don't agree to that. Okay. Now, how come the gradient of a horizontal line is 0? You see this line? I am taking its 2 points. What is this point? I guess it is 2, 2. Move bit. What is this point? This is 7, 2. Now find the gradient. What will be the gradient? y2 minus y1 over x2 minus x1. 0 over 5, 0. Gradient of any horizontal line is 0. Look at this line. This is 6, 1, this point. This point is 6, 6. So let us find its gradient. Gradient is equal to y2 minus y1, 6 minus 1 over x2 minus x1. This is 5 over 0. Some people say this is infinity, which to me is wrong. It is undefined. The gradient of any vertical line is undefined. Now, let me recall in brief what we have learned so far. We have learned that gradient of a line is the tangent of the angle formed by the line with x-axis. How do we calculate the gradient if we are given 2 points? The formula is y2 minus y1 over x2 minus x1. Number 3, what is the gradient in term of steepness? What is the gradient of a rising line? What is the gradient of the falling line? What is the gradient of the vertical line? And what is gradient of a horizontal line? So we have learned so far these few things. We have also solved some questions in which we calculated the gradient where we were given 2 points of a line. The next concept is very important. This is about collinearity of 3 points. Dear student, if we have 3 points in the Cartesian plane, suppose this A, B and C. I join A to B, this is a line. I join B to C, this is another line. And I join A to C, this is another line. These are 3 different lines. A and B lie on line L1, but C does not lie on this. B and C lie on line L2, but A does not lie on this. A and C lie on line L3, but B does not lie on this. So we say these 3 points are not collinear. Collinear, co means same, linear line. They are not collinear. But if these points are in such a way that a line joining the point AB extended passes through C, then you see these 3 points are lying on the same line as P, Q and R are here in the given figure. I think the collinearity concept is clear. If 3 lines lie on the same single point, 3 points lie on the same single line, they are called collinear. How do we mathematically check that these 3 points, the given 3 points, are whether they are collinear? So we need to understand this concept. This is the line and PQR lying on this. This is the angle theta which this line forms with x-axis. Look at this. What will be this angle? Theta. What will be this angle? Theta. So can I conclude the gradient of PQ will be same as gradient of QR if they are collinear? Yes. If they are not collinear, the gradient of any two of them will never be equal. If 3 points are collinear, gradient of any two of them will give us same value. That is, gradient of PQ will be equal to gradient of PR will be equal to gradient of QR. This is the test which we perform to check the collinearity of the 3 points. Let us solve few examples. In each of the 3 parts of this question, we are given 3 points and we have to check the collinearity. I am solving the part 1. First point is 1, 4. Second point is 3, 0. And third point is 5 minus 4. First of all, let us find M1, gradient of PQ. Gradient of this line. What is x1? 1, y1, 4, x2, 3, y2, 0. Put the formula. y2 minus y1 over x2 minus x1. Its gradient is negative 2. Now we calculate gradient of either QR or PQ. Gradient, I am calculating the gradient of QR. So what is x1? 3, y1, 0, x2, 5, y2, minus 4. So I will put in the values y2 minus y1 over x2 minus x1. This will be minus 4 over 2, which will again be minus 2. Are these two gradients same? Yes. So the points P, Q, R are collinear. Given points are collinear. So this is the application of gradient. We check the collinearity of 3 points. If 3 points are not collinear, then they 3 will form a triangle. We are going to use this concept in next lesson, inshallah. Whether the 3 points in the plane will be collinear or those 3 points will form the vertices of a triangle. And if the area of triangle is 0, again points will be collinear. This concept will be used in later classes. You will solve the other 2 parts by yourself. I am solving another question. We have to show that these 3 points are collinear. No. The first point P is equal to 1 minus 1. Second point Q is equal to 5, 5. Third point R is equal to minus 3, minus 7. Gradient of PQ, I will call it M1, and gradient of QR, I will call it M2. For gradient of these 2 points, 5 plus 1 over 5 minus 1, 6 over 4, 3 by 2. And for the gradient M2, y2 minus y1 minus 7 minus 5 minus 3 minus 5. This will be minus 12 over minus 8, which will be again 3 by 2. These two gradients are equal. M1 is equal to M2. Points are collinear. I hope this is clear. So far we have learned about the gradient. What is gradient? Gradient of a line is the tangent of the angle which the line forms with x-axis. How do we calculate the gradient? y2 minus y1 over x2 minus x1, where x1, y1, x2, y2 are points of a given line. Number 3, how do we calculate what is the gradient of horizontal line? What is the gradient of vertical line? And number 4, how do we check the collinearity of 3 points? Please do solve this question by yourself. At the end of today's lesson, we will learn a relation between the gradient of parallel and perpendicular line. It's very obvious. Suppose there are two lines L1 and L2. Gradient of L1 is M1, gradient of L2 is M2. If these two lines are parallel, their gradients will be same. It is very easy. These two parallel lines will form the same angle with x-axis and hence their gradient will be equal. And if these L1 is perpendicular to L2, then this is very important result. Product of their gradient will be -1. That is, gradient M1 is equal to -1 over M2 or M2 is equal to -1 over M1. In other words, we can say that gradient of two line will be same if they are parallel and the product of their gradient will be -1 if they are perpendicular. The second part is very important. If gradient of first line is 3/4, then gradient of any line which is perpendicular to this line will be negative reciprocal of this 3/4. We will take the reciprocal as well as change the sign to get the gradient of other line. The gradient of two perpendicular lines are negative reciprocals of each other. I have chosen an example. Are the line L1 and L2 passing through the given points, pair of points, parallel, perpendicular, or neither parallel nor perpendicular? There are three parts to this question. This is the last question for today. In each part, we are given 2 points of one line and 2 points of another line. We have to check whether these two lines are parallel, perpendicular, or neither. How will we check? We will find the gradient of both the lines. If they have same gradient, the lines will be parallel. If their gradient are negative reciprocal of each other, or in other words, we say that their product is -1, then they will be perpendicular. And if this is not the case, then they will neither be parallel nor perpendicular. So in the first part, let us find the gradient of first line and gradient of second line. What is x1? 1, x2, y1, 2, x2, 3, y2, 1. Put in the formula y2 minus y1 over x2 minus x1. What will I get? -1 over 2. This is the gradient of first line. For second line, x1, y1, x2, y2. This will be y2 minus y1 over x2 minus x1. This will be 1 over 2. Are these two gradients equal? No. So lines are not parallel. Is their product -1? No. The product of these two is -1/4. 1/2 into -1/2 is -1/4. So they are neither parallel nor perpendicular. So we will say lines are neither parallel nor perpendicular. I hope this is clear. Similar same question with the 2 points are different. I am rapidly solving it. M1 is equal to 1 minus 3 over 3 minus 0, which is equal to -2 over 3. M2 is equal to -5 minus 4 over -7 plus 1, which is -9 over -6, which is 3/2. Are these two equal? No, lines are not parallel. Is their product equal to -1? Are they negative reciprocal of each other? Yes, lines are perpendicular. I hope this is clear. The last part for today's lesson. Gradient of first line is y2 minus y1 over x2 minus x1. This is minus 6 over 3 minus 2. M2 is equal to y2 minus y1 over x2 minus x1, 2 over minus 1. Again, minus 2. Both these gradients are equal. Lines are parallel. Dear student, this is all for today. In today's coordinate geometry lesson, we learned the geometrical interpretation of gradient, formula to calculate the gradient, relation between the gradient of parallel perpendicular lines, and also how to check the collinearity of three different points. We also learned that gradient of any horizontal line is 0 and gradient of any vertical line is undefined. We also learned that the gradient of any line which is rising is positive and any line which is falling is negative. In next lesson, inshallah, we will move towards forming the equation of a straight line. Thanks for watching. Please do subscribe this channel so that you get timely notified whenever any new video is uploaded.